Welcome to Vision Plus and welcome back to S.4 Mathematics. We are looking at turning points of the curve. Example 3 part A says, identify the turning points of the curve y equals to 2x squared plus a third x cubed. And this question is not complete and distinguish them. Now, for us to get the stationary points of the curve, we need to get the gradient function of the curve. Therefore, we differentiate the given function of the curve. So dy dx becomes 4x plus x squared. This is the gradient function of the curve at any point on the curve. What do we know at the turning point? We know that at any turning point, dy dx is 0. In other words, the gradient of the curve at a turning point is 0. So at any turning point or at a turning point, dy dx is 0. This implies that the gradient of the curve at a turning point is 0. Since we know this, we can use this concept to get the coordinates of the point at the turning point. Therefore, from here we substitute dy dx is 0. So we shall have 0 equals to 4x plus x squared. This is a quadratic equation. Now, this will assist us to find the coordinates of x at the turning point. Since it has a degree of 2, we shall have 2 turning points. So, from here, we find x. We can factorize this side so that we have 0 equals to x is common into 4 plus x. And since it is equated to 0, either of the terms, either x equals to 0, therefore in this case x is 0, or 4 plus x is 0, for which case x is negative 4. Therefore, here x is negative 4. So we have two values of x. That means there are two turning points. This means that we have the 2 points. This means that we need to also get the corresponding values of y. So when x is 0, for x is 0, that is at one turning point. So when x is 0 at one turning point, what is the corresponding value of y? Because a turning point is a coordinate. So we come and use the equation of the curve and we substitute for x. So we shall have y equals to 2x is 0 squared plus a third x is 0 but cube. This implies that here we shall have 0. So if x is 0, y is 0. So the point is 0, 0. That means that the point 0, 0 is a turning point. And then what if x is negative 4? That is at the other turning point. So for x equals to negative 4, what is the corresponding value of y? So we shall use the same expression. Y equals to, substitute for x as negative 4. 2 times negative 4 squared plus the third times negative 4 cube. And then you press your calculator to see 0 and get those values. Negative 4 squared positive 16 times 2, 32. Here I'm getting 32. Negative 4 cube is negative 64. Divide by 3, it is fraction. So here we shall have negative 64 out of 3. And then you subtract 32 minus 64 out of 3. I'm getting 32 out of 3. I'm getting 32 out of 3. Let me prove again. This is 16 32 and negative 4 power 3 divided by 3 gives that negative plus 32. Yes, I'm getting 32 out of 3. So this is the value of y. So the other turning point is negative 4 and then 32 out of 3. Those are the two turning points that we have. But if you come to the question, it says that identify the stationary points, which we have done. But now we need to distinguish them. That implies that we need to tell whether the first point is a maximum, minimum, or a point of inflection. The second point, whether it is a maximum turning point, minimum turning point, or point of inflection. So for us to distinguish, we use the second derivative. Second derivative. There's another method of testing for slope, but I'm not doing that one. So in the second derivative method, we simply notify the second derivative of the function. So this is the first derivative. Let me quote it here that dy dx equals to 4x plus x squared. Now we need to differentiate this function for the second time to give us the second derivative. B squared y x squared equals to 4x. If we differentiate 4x, we get 4 plus if we differentiate x squared, we get 2x. This is now the second derivative. Now we need to test for the 2 points, this and that. So for the first point, which is 0 0, I'll test it here. For the second point, which is negative 4 and then 32 out of 3, I'll test for it there, whether it is maximum, minimum, or point of inflection. Now for the first point, we use the second derivative, even for the second point. Remember, this is coordinate x, this is y. So we substitute x there, so that we have d squared y, x squared equals to 4 plus 2 times x, which is 4. This gives us, x is not 4 please, sorry, x is 0, x is 0 times 0, okay, x is 0. So 4 plus 0 is 4. Now we have got 4 in the second derivative. Then we judge, is 4 more than 0, is it equal to 0 or less than 0? 4 is more than 0. So we say that if d squared y, the x squared is more than 0, then we have minimum turning point, or it is a minimum stationary point. Therefore, the point 0 0 is a minimum turning point, or you can say is a point of minima. Is a point of minima. And then in the same manner, to test for the second point, this is x, this is y. Substitute for x in the second derivative, so that we have d squared y, the x squared equals to 4 plus 2 times x. X is negative 4. This here gives us negative 8 plus 4 is negative 4. We check, is negative 4 more than 0? Is it equal to 0 or it is less than 0? Negative 4 is less than 0. And we say that if the second derivative is less than 0, then it is a maximum turning point. It is a maximum, our markers is a maximum turning point. That implies that the point -4, 32 out of 3 is a maximum turning point, or it is a point of maxima. So this is the solution to example 3 part A.